Imagine stepping into a machine, pressing a button, and in an instant, you're standing on the red sands of Mars, watching humanity's first colony take shape. Or standing in ancient Egypt, witnessing the Great Pyramids being built stone by stone. It sounds like science fiction, doesn't it? But what if it's not? Could time travel become a reality in our lifetime? And if it did, would it unlock the secrets of the universe or rewrite the fate of humanity? The science of time travel isn't just a dream, it's closer than you think. Scientists have uncovered ways in which time can stretch, bend, and even loop back on itself. Could we ever build a time machine? Could we rewrite history or glimpse humanity's distant future? Stay with me, because the answers we uncover today might just redefine what you think is possible. To understand time travel, we need to rethink what time really is. Most of us imagine it as a straight line, past, present, future. But physicists see time differently. It's more like a river, flowing, bending, even pooling in some places, depending on the forces acting on it. Einstein's theory of relativity transformed our understanding of time. He showed that time and space are intertwined into a single fabric called space-time. And just like fabric, space-time can stretch or warp. Massive objects like stars and planets create dents in space-time, slowing time in their vicinity. This effect, called time dilation, is more than just theory. It's been proven. Astronauts aboard the International Space Station, moving faster than people on Earth, age ever so slightly slower. And if you could travel near the speed of light, time for you would slow down dramatically. Imagine returning to Earth after a year-long journey, only to find that decades have passed for everyone else. That's the future. But what about the past? Is there a way to turn back the clock? Imagine the universe as a giant sheet of paper. If you fold it in half and punch a hole through the middle, you've created a shortcut between two distant points. This shortcut is what physicists call a wormhole, a tunnel that could connect different places and potentially different times. Wormholes aren't just theoretical, they're predicted by Einstein's equations. But here's the catch. Wormholes are unstable. The moment anything tries to pass through, they collapse like a bridge made of sand. To stabilize a wormhole, we'd need something extraordinary: exotic matter. Exotic matter isn't like anything we've ever encountered. It's a hypothetical substance that defies gravity, pushing instead of pulling. If exotic matter exists, it might keep the wormhole open long enough for us to step through. But exotic matter remains hypothetical, and the energy required to create a stable wormhole would dwarf the output of our sun. Still, the idea of stepping into one end and emerging in another galaxy or another time remains one of the most tantalizing possibilities in science. If relativity bends time, quantum mechanics shatters it entirely. In the quantum world, particles don't follow the neat rules of classical physics. They pop in and out of existence, appear in multiple places at once, and sometimes even travel backward in time. One of the most fascinating phenomena in quantum physics is quantum tunneling. Imagine throwing a ball at a wall and watching it appear on the other side without breaking anything. This strange phenomenon isn't just theoretical. It's used in technologies like quantum computing. Could it one day help us bypass the normal flow of time? Then there's the idea of closed time-like curves, theoretical loops in space-time that allow objects to revisit their past. Closed time-like curves are like a looped racetrack in time. Imagine racing back to a previous lap to see yourself on the track. Only now, you're both the observer and the observed. But even as we explore time's quantum mysteries, a bigger question looms. What happens when we try to change it? Time travel might be possible, but it comes with a serious problem: paradoxes. These logical puzzles highlight why altering the past could have devastating consequences, or might be impossible altogether. The grandfather paradox is the most famous example. Imagine going back in time and preventing your grandparents from meeting. If they never meet, you're never born. But if you're never born, how could you go back in time to stop them? Then there's the bootstrap paradox, where an object or idea exists without an origin. Imagine discovering a book of inventions, traveling back in time, and handing it to its author. Who created the book? These paradoxes challenge our understanding of cause and effect. Would rewriting the past mean erasing ourselves from existence, or creating a version of reality we could never return to? Some scientists speculate that the universe might prevent paradoxes altogether, perhaps by ensuring that time travel only works in ways that preserve the timeline. Others suggest that traveling to the past might create entirely new timelines, leaving the original unchanged. Time travel isn't just about physics, it's about our deepest desires. The idea of fixing mistakes, witnessing history, or exploring the future speaks to something fundamentally human. From H.G. Wells's The Time Machine to Christopher Nolan's Interstellar, time travel stories resonate because they ask profound questions. What is our place in the universe? What would we change if we could? And here's the incredible part. The boundary between science fiction and reality is constantly shifting. Ideas once thought impossible, flying, exploring space, are now everyday realities. Could time travel follow the same path? Time travel is more than just a dream. It's a challenge. The science shows us it might be possible, but the hurdles are monumental. Still, humanity's greatest achievements often begin as impossible ideas. Right now, you're traveling through time. Every second that passes is a step into the future. The real question is, how far will we go? Time isn't just the measure of moments. It's the canvas of our existence. And one day, we might learn to travel across its endless expanse, redefining what it means to be human. If you found this journey as fascinating as I have, share it with someone who dreams of exploring the universe. And let us know in the comments. If you could travel through time, where would you go? And why? Time is waiting. Are you ready to take the leap?